Comparison tests ask whether groups differ. Regression asks something richer. How does one thing predict another? What drives a home's list price? Square footage, surely, but also bedrooms, bathrooms, age, all at once. Linear regression fits an equation that predicts the price from a weighted combination of those predictors, choosing the coefficients that make the predictions miss by as little as possible. You don't write a formula by hand. I pick the response, add my predictors in the model builder, and the model fits live. At the heart of the output is the coefficients table. Each predictor gets an estimated effect, holding the others fixed, with a p-value telling you whether that effect is real, and R² tells you how much of the variation the model explains. Watch out though. Plain R² always rises when you add a predictor. The adjusted version only climbs when a predictor earns its place. A high R² doesn't mean the model is sound. So I check the residuals. The gaps between predicted and actual. Stratum draws the standard diagnostic plots. A curve means a line was the wrong shape. A widening funnel means the error spread grows. And a few far-out points are influential. Cook's distance flags them. When two predictors carry the same information, the model can't separate their effects. That's multicollinearity, and the variance inflation factor measures it. A value past 5 to 10 is a warning. With many predictors, best subsets ranks the leading models, so I can balance fit against simplicity and avoid overfitting. Finally, I add a predicted price column, and the model becomes part of my data. Next, data that moves through time.